This is my geometry course. Today you're going to learn the basics of triangles, and we're going to learn two of the most important theorems in mathematics, the Pythagorean Theorem and the Triangle Sum Theorem. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're first going to classify triangles. You can classify triangles by sides or by angles. If we want to classify triangles by sides, we have a scalene triangle. In a scalene triangle, all three side lengths are different. That's called a scalene triangle, when all the lengths are different. But there's an isosceles triangle where two sides have the same length, and the third side is a different length. And then we have an equilateral triangle where all the side lengths are equal. Now we can also classify triangles by angles. If a triangle, if all the angles in a triangle are acute angles, meaning they're less than 90 degrees, then that's called an acute triangle. But if we have a triangle where one of the angles is an obtuse angle, an angle that is greater than 90 degrees, that's called an obtuse triangle. And these other two angles, they would have to be acute angles. And then we have a very special triangle called a right triangle, where one of the angles is a right angle. It measures 90 degrees. That's called a right triangle. And then we have an equiangular triangle where all the angles are the same measure. So let's get to the important stuff today. The first thing that we're going to go over, that's the first theorem, is the Pythagorean Theorem. Now, before we talk about what this theorem is, we have to name the lengths of a right triangle. The longest side of a right triangle is called the hypotenuse. And the hypotenuse is always opposite the right angle. You see this right angle here? This side is opposite that angle because it's right across from it. That's what we mean when we say it's the opposite side of that angle. So remember, the hypotenuse is always across from the right angle. And like I said, it's the longest side. It's called the hypotenuse. These other sides are called the legs. This side is called a leg, and this side is called a leg. So the Pythagorean theorem says that if A and B are the legs of a right triangle and C is the hypotenuse, then in every right triangle, a squared plus b squared is equal to c squared. So the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Now, I know that seems kind of complicated, but don't worry if you don't understand exactly what that means. We're going to go over a lot of practice problems, and you're going to see exactly how that works. Now, when it comes to the proof of this theorem, I'm not going to prove the theorem right now. We might prove it towards the end of the course if we have time, but I'm not going to prove it. And the reason I'm not going to prove it is that there's two reasons. One, if I take 100 high school seniors or even 100 college students, I would be shocked if even one of them could prove the Pythagorean theorem, because you're just not required to prove this theorem in school. It's just not something you're required to do. And the second reason I'm not going to prove it is that this geometry course has a lot of material in it, and the material can be very challenging, so I'm not going to force you to prove this theorem when you don't really need to do it, because that's just adding unnecessary difficulty. So we're not going to prove the theorem now. I'd like to prove it. I'd like to show you some proofs, but it's just not necessary at this point, so we're not going to do that. So anyway, you might want to get a screenshot of this. And now we're going to do some practice problems. So if you didn't understand that Pythagorean theorem, that's okay. We're going to do some practice problems, and you're going to see how this works. Now, an extremely important thing to understand is that this theorem only works for right triangles. You must understand that. Don't try to use this theorem for other triangles. It's not going to work. That's the most important thing to understand about the Pythagorean theorem, is it only works for right triangles, meaning a triangle where one of the angles is 90 degrees. All right, so you can see we have right triangles here, and it says find the missing side of each right triangle. So we have this side and we have this side, but we're missing this side. So we're going to use the Pythagorean theorem to solve this problem. So let's write the Pythagorean theorem down. A squared plus b squared equals c squared. Now, the most important thing to understand is what numbers to plug in, or where to plug the numbers in. A lot of the biggest mistake that students will make is they'll accidentally plug in one of these numbers to c. That is wrong. Because remember, this c value has to be the hypotenuse. The hypotenuse is always opposite the right angle. So the hypotenuse is going to be x. These are the legs. So we can plug in 5, and we can plug in 12, and we're going to plug in x for the hypotenuse. The hypotenuse has to be c in every single case. Now you're probably thinking, wait a second, how do we know that 5 goes here? Why doesn't 5 go here? Well, it actually doesn't matter. It doesn't matter if 5 goes, it doesn't matter if 5 is A or B. That doesn't make any difference because of the commutative rule of addition. But if you plug in 5 for C or 12 for C, then you've got a problem. You're going to get the wrong answer. Now again, if you're a little confused by that, that's okay. You're going to get the hang of it as we do more practice problems. The other thing that we need to go over is, I want to make sure that you remember what second power means. Remember, if you raise something to the second power, that means you're taking 5 and multiplying it by itself. So I'm not going to do this in every problem, but I just want you to remember what that means. 5 times 5 is 25, and 12 times 12 is 144. If you don't know that, just look, plug it into your calculator. 25 plus 144 is 169, and now you can see we're getting closer to solving this equation. We're looking for x. So again, that's what raising to the second power means. You need to remember that for the rest of the problems. We're going to do a lot of practice problems before you try one on your own, but that's something you're going to need to keep in mind. Now, we have solved for x squared. We don't want x squared. We don't want that. We just want x. So we have to get rid of this power here. So we're going to have to do the opposite of raising to the second power. The opposite of raising to the second power is square rooting. The opposite of squaring, remember squaring is the same thing as raising to the second power. The opposite of squaring is square rooting. So we're going to square root both sides. And remember, whenever you square root both sides, you have to put plus or minus. Now, if you plug in 169 to your calculator, because that's kind of a big number, we're asking, when you square root a number, you're asking what number times itself is equal to 169. Again, that's kind of a big number, so you can plug that into your calculator. If you have an iPhone, the button is going to look like this. So you plug in 169, and then you push this button, and that will give you 13. So what that means is 13 times 13 is 169. And the square root gets rid of the square. That's why we did that. So now we see that x is equal to plus or minus 13. But you need to understand that even though the correct answer for this equation is plus or minus 13, it's impossible to have a negative length. You can't have a negative length, so we can just get rid of those plus or minuses. But I just wanted to show you those plus or minuses to let you know that usually when you square root both sides of an equation, you have to keep the plus or minus sign. So what does this mean? Well, this just means that we use the Pythagorean theorem to find that this side is 13. All right, so I know that's throwing a lot at you all at once here, but again, we're going to do a lot of these problems. You'll have plenty of practice. This is one of the most important theorems in all of mathematics, so it's important that you understand this. So again, we have a right triangle. And again, this theorem only applies to right triangles. I know these are right triangles because I have a right angle there and I have a right angle here. So I'm going to write the tool that I'm going to use. And I'm going to plug in the legs and the hypotenuse. Now again, y is the hypotenuse. How do I know that? I know y is the hypotenuse because it's opposite the 90-degree angle. So far in these problems, the missing number has been the hypotenuse. We're going to deal with problems where the missing number is a leg later on. So the hypotenuse is y, that plugs in for c. And then 1 to the second power, what does that mean? It means 1 times 1. So obviously that's just 1. 2 to the second power, what does that mean? That means 2 times 2. So that's 4. Now all we have to do is solve this equation. 1 plus 4 is 5. And we've isolated the square. Y squared equals 5. But we don't want y squared. We want y. So we have to square root both sides of the equation. Remember, whatever you do to one side of the equation, you have to do to the other side of the equation. So we have root 5 is equal to y. And we're not going to write plus or minus because, again, there's no such thing as a negative length. That is the answer. Now, you may get some problems where you're asked to estimate, or actually not estimate, but round off the answer. If you plug in 5 to your calculator, and then you push this button, if you're using an iPhone, you push that button, then you get 2.236 and on. So you'd have to write squiggly lines, meaning approximation. You'd have to write 2.23606, and it would just go on and on and on. So we don't want to do that because we can just write the exact answer, which is root 5. So we're just going to leave it as root 5. Let's try another one of these problems. Again, you need to write the tool that you're using. We're using the Pythagorean Theorem. And we're going to plug in 5. We're given the legs. They're both 5. And the hypotenuse is k. 5 times 5 is 25. 5 times 5 is 25. Now we're just going to add 25 plus 25 is 50. And we've isolated k squared, but we don't want k squared. We want k. So we're going to have to get rid of that power, and we're going to square root both sides. And then we end up with k is equal to square root 50. Now this is going to be something a little different here. This is where students are going to get a little anxious, a little nervous about this. We can't leave our answer as square root 50. I mean, we can, but in school they usually don't let you do that. Teachers don't let you leave it like that. And the reason is there's a perfect square factor in 50. So what we're going to do is we're going to have to factor 50. Now I can factor it to 5 times 10, but the problem is neither 5 nor 10 are perfect squares. So I'm going to have to factor it to 25 times 2. And that's the factorization we're looking for because 25 is a perfect square. At that point, I can then break up that expression to root 25 times root 10. Now you're probably thinking, I don't understand that. How can you do that? That's not correct. You can't do that. I don't get it. Well, remember, you learned in my previous class, root a times b is equal to root a times root b. Or root a times b is equal to root a times root b. Now, it's okay if you don't remember this. It's been a while since my last course. So it's okay if you don't remember this, but don't claim that you've never seen this. I don't want to hear that you've never seen this. You have seen this, you just maybe don't remember it. So we use this rule to go from here to here. And so you're probably thinking now, okay, well, so what? Well, who cares? Why do we do that? Well, square root 25, again, that's just square root is just asking you what number times itself is equal to 25. Well, obviously that would just be 5. So what we did is we pulled the perfect square out of the root. And now we can just get rid of that dot and just write the 5 right next to the square root. When you write any number next to a square root, that just means you're multiplying the number. And that is the answer. So again, you're thinking, I don't understand why we had to do that. Well, we don't really have to do it. We can leave the answer like this, but in school, they always want you to pull the perfect square out of, if you do have a perfect square factor, they want you to pull it out of the square root. Now, again, you may be a little rusty on that, but that is part of my beginning algebra curriculum, and beginning algebra is a prerequisite for this course. So it's okay to say that you don't remember this. It's not okay to say that you never learned it. You did do this in my previous course. Now, I'm not going to go over this and do a bunch of practice problems because we just don't have time for that right now. But if you want to go back and review that in my beginning algebra course, you can look under the class entitled Square Roots or something relating to square roots, and you can find it fairly easily. All right, I'm going to put a little divider there. So now it's time for you to try. Go ahead and try number 4, and remember, the first thing that you have to do is write the tool that you're going to be using. This is all about the Pythagorean Theorem. So the tool we're using is the Pythagorean Theorem. You're going to write that equation down first, and then you're going to plug in the numbers that we know and solve for the number that you don't know. And y is opposite the right angle, so y is going to be the hypotenuse, so you're going to plug in y to c. And 3 and 4 are going to be plugged in to either a or b. You can plug in the numbers to either a or b, it doesn't really matter. But if you plug in 3 or 4 to c, then you're going to get the wrong answer. So remember, that's the danger you have to watch out for. So try number 4, and when you come back, we'll do it together. All right, we're back. 3 squared plus 4 squared equals y squared. You need to plug it in that way. Now again, you could put the 4 in front. You could plug in 4 for A and 3 for B. You're gonna get the same answer. It doesn't matter because of the commutative rule of addition. But if you plug in 3 or 4 to the C value, then you've got a problem. You're going to get the wrong answer. 4 to the second power, 4 times 4 is 16. 3 times 3 is 9. Now we just have to solve that equation. 16 plus 9 is 25. Now we've solved for y squared. We don't want y squared. We want y. So we have to get rid of that 2 power. The opposite of squaring is square rooting, so we're going to square root both sides of the equation, because whatever you do to one side of the equation, you have to do to the other side of the equation. And that gets rid of the 2 power, so you're just left with y. And the square root of 25, that's asking what number times itself is equal to 25. So pause for a second and see if you can do that. What number times itself is 25? Well, if you know your multiplication facts, you know that it's going to be 5. So if you got 5, good job. If you got stuck, that's okay. We're going to do more problems, so you're going to get plenty of practice with this. All right, on to number 5. That was your first problem that you tried there. Now I want you to try number 5. And when you come back, we'll do it together. Remember, you got to write that tool. You got to show the tool that you're using. It's the Pythagorean Theorem. And plug in the numbers that you know and solve for the numbers that you don't know. When you come back, we'll do it together. All right, we're back. 3 squared plus 5 squared equals m squared. If you didn't plug it in that way, then you're not going to get the right answer. 3 times 3 is 9. 5 times 5 is 25. 9 plus 25 is 34. And we've solved for m squared, but we don't want m squared. We want m, so we have to square root both sides to get rid of that 2 power on the m. And that gets rid of the 2 power, and then we're just left with square root 34, and that's all you can do. You could use a calculator to approximate the answer, but why would we do that when we can just write the exact answer, square root 34? So, and there's not a perfect square in 34. The only factorization is 2 times 17. So neither 2 nor 17 are perfect squares, so we can just leave it like that. So if you got square root 34, good job. All right. Now let's try number 6. For number 6, you're going to have to do this type of math here where you pull out a perfect square. So you might want to take a screenshot of number 3, and you might use this information also. And try number 6, and when you come back, we'll do it together. All right, we're back. Let's write the tool that we're going to use first. the Pythagorean Theorem. And we're going to plug in 2 and 4. Whoops, that should be an L. We're plugging in L as a hypotenuse. 2 times 2 is 4. 4 times 4 is 16. 4 plus 16 is 20. And we've solved for L squared. We don't want L squared. We want L. So we have to square root both sides. And that gets rid of the 2 power, and you're left with L is equal to square root 20. But the problem with square root 20 is it has a perfect square as a factor. So again, mathematicians don't like leaving square roots with perfect square factors. So what we're going to do is we're going to factor 20. Now, if I factor 20 to 2 times 10, that doesn't do anything because neither 2 nor 10 are perfect square factors. But if I factor 20 to 4 times 5, that does something because 4 is a perfect square. Then I'm going to break it up to square root 4 times square root 5. And square root 4, that's asking what number times itself is equal to 4. So what number times itself is equal to 4? Well, that's just 2. 2 times 2 is 4. And then we can get rid of the dot, because again, when you put a number right next to a root, that just means 2 times root 5. And that is our answer. So if you got that answer, good job. If you got stuck, that's okay. Just go back and look what you did. And you'll have a chance to do another problem as we go along here. All right, on to the next problem. Now, in these next problems, something different is going to happen. We're still going to use the Pythagorean Theorem. So we're going to write that tool that we're using. But in these problems, we're actually given the hypotenuse. In the previous problems, we were asked to find the hypotenuse. We didn't know what the hypotenuse was. Y and X are both the hypotenuse, and we're given the legs. We're given the legs in these problems, but we're trying to find the hypotenuse. Notice that the variables are always opposite the 90-degree angle. Opposite the 90-degree angle. But in these problems, we're not asked to find the hypotenuse. They actually give us the hypotenuse. It's 10. Again, this is the 90-degree angle. The side opposite the 90-degree angle is this side here, which is the hypotenuse. It's always the hypotenuse, opposite the 90-degree angle. So that side, they actually give us that side. In this problem, they're asking for a leg. We're missing a side length of a leg. So these problems are going to be a little different. So we can plug in 6, that's one of the legs, but X is going to be the other leg. We don't know what the other leg is, and the hypotenuse is 10. So the difference with this problem is that one of the variables is on this side of the equation. So now at this point, all we have to do is just solve the equation. It's an equation with a square. Now, in my previous course, beginning algebra, we learned that to solve an equation with squares, you first isolate the square. You're going to get x squared by itself. X squared is not by itself because the 6 squared is next to it. But before we do anything, we're going to go ahead and square 6. 6 times 6 is 36. And 10 times 10 is 100. And then we're going to take this 36 and get it away from the x squared, subtract 36 from both sides, and we get 64. So you can see this problem is, or this equation is becoming simpler and simpler as we go along. So now we've solved for x squared. We don't want x squared. We want x. So we have to square root both sides. And now we have x is equal to 8, and that is the answer. So we were looking for a leg on that problem. We found that the leg is 8. All right, so let's go on to number 8. So again, we're going to write the Pythagorean Theorem. We have to show the tool that we're using. Now again, the missing side is a leg. We know that root 29 is the hypotenuse because it's right across from the 90-degree angle. That's always so if you're dealing with a right triangle. So we're going to plug in 5 for A and S for B and root 29 for C. And it's probably best that you write parentheses there. You may not have to write parentheses, but I think it would just be best so you know it's inside the square. And we haven't seen this before. We haven't seen this expression, at least not in this course. So first, let's go ahead and square 5. 5 times 5 is 25. But how do we deal with this? Well, again, raising to the second power, squaring is the opposite of square rooting. So all the second power does is just get rid of the square root, so you're left with 29. And now we have to isolate s squared. It's not isolated, it's not by itself because the 25 is next to it. So we subtract 25 from both sides, and that makes it disappear on the left side. And 29 minus 25 is 4. So now we've isolated s squared, but we don't want s squared. We want s. So we have to get rid of the second power. So we have to square root it, and that gets rid of the second power here. But if we square root the left side, we have to square root the right side also. So that gets rid of the second power, and we have to ask ourselves, what number times itself is equal to 4? That's what square root means. What number times itself is equal to 4? Well, obviously that would just be 2, so s is equal to 2. All right, so hopefully you're getting the hang of this now. On to problem 9. The most important thing is that you understand the Pythagorean theorem. Some of these math principles you may need to review by going back to my beginning algebra course. But the most important thing is to understand the Pythagorean theorem. A squared plus b squared is equal to c squared, and c is the hypotenuse of the right triangle, and a and b are legs of the right triangle. And it doesn't matter which order you put the legs, as long as you don't accidentally stick a leg into the hypotenuse, or a hypotenuse into a leg. And probably the most important thing, more important than anything else, is to know that this Pythagorean theorem only works for right triangles. Notice every single triangle we're working with here is a right triangle, and I know that because of this little box here. That means that angle is 90 degrees. So let's plug in the numbers. Square root, actually that's the wrong one. I just did the very thing I was warning you against. 3 root 5, that's the hypotenuse. And x is a leg. It can go here or it can go here. It doesn't matter. And again, the difference with these problems is that now we're missing a leg. In the previous problems, we were missing the hypotenuse, but now we're missing a leg. So we're going to go ahead and square the numbers. So 6 times 6 is 36, and 3 root 5 times 3 root 5. Now we're going to go ahead and write that out. You learned how to do that in my previous course. Again, when you raise something to the second power, all that means is that you're multiplying it by itself. So I'm writing this out. I don't have to write this out. You don't have to write this out, but I'm just doing this so you can see what's going on here. And again, it's been a while, but we learned how to do this in my beginning algebra course. 3 times 3 is 9. We just multiply these numbers. And then root 5 times root 5. Well, whenever you multiply a root times itself, well, that would just be root 25, but root 25 we know is 5. So again, I'm not going to go back over this stuff. Because again, this is all stuff we went over in my beginning algebra course. We don't really have time to go over all this now. So at this point, we go ahead and multiply. 9 times 5 is 45. So we have x squared plus 36 is equal to 45. Now you're going to come across this situation many, many times in your math courses where you run out of room on the paper. If you run out of room, don't panic. You just put a little arrow and you go up and you can finish. So now we're going to isolate the x squared. The x squared is not isolated because 36 is next to it, so we're going to subtract 36 from both sides, and we're going to get x squared is equal to 9, because 45 minus 36 is 9. Now we're going to square root both sides, and what number times itself is equal to 9? Well, 3 times 3 is equal to 9, so x is equal to 3. And I'm sorry that got that red line is in the middle there, so we can't hardly see that. But that's pretty much how this works. Again, the difference with these problems is that the missing side is a leg instead of the hypotenuse. So you got to be really careful when you plug these numbers in that you're not plugging the number in a leg to a hypotenuse or the hypotenuse to a leg. So now it's time for you to try. Try number 10, and when you come back, we'll do it together. All right, we're back. We have to show the tool that we're using, which is the Pythagorean Theorem. Then you can plug in 8. 8 is one of the legs. But 17 is not one of the legs. 17 is a hypotenuse because it's opposite the 90-degree angle. So you have to plug in 17 to C. Don't plug it into B. P is going to be B. So now 8 times 8 is 64. And 17 to the second power, 17 times 17, that's 289. You can always use your calculator for that if you need to. That's just 17 times 17. Now we're going to subtract 64 from both sides because we need to isolate p squared, and we end up with 225. So now we're going to get rid of that second power on the p, and we're going to square root both sides of the equation, because square rooting is the opposite of squaring. And again, we're out of room here. I can move this up though. And our final answer is P. Now again, this is kind of a big number, so it's kind of difficult to see what number times itself. Because again, when you square root a number, you're asking what number times itself is equal to 225. So that's not easy. So you can plug in 225 to your calculator, and then you can push this button if you're using an iPhone. And that will give you the number that we're looking for, which is 15. So if you got 15, good job. So try number 11, and when you come back, we'll do it together. All right, we're back. First, write the tool that you're using. We're using the Pythagorean Theorem. And V is one of the legs, and 1 is one of the legs, but root 17 is a hypotenuse. Now, how did I know that root 17 was a hypotenuse? Because root 17, this length here, is right across from the 90-degree angle. So I knew that must be the hypotenuse. And it doesn't matter if V goes here and 1 goes here, or if V goes here and 1 goes here. You're going to get the same answer because the commutative rule of addition. So now 1 times 1 is 1, and root 17 times root 17 is just 17. Again, the second power is the opposite of square rooting, so it just gets rid of the square root. Squaring is the opposite of square rooting. So now we just have to isolate the square. You learned in my beginning algebra course that we need to isolate that square. So we're going to get rid of the 1, subtract 1 from both sides, and we get v squared is equal to 16. So we isolated the square, but we don't want v squared, we want v. So we have to get rid of that 2 power on the v and square root both sides. So now we have v is equal to what number times itself is equal to 16? Well, obviously that number would be 4. So if you got 4, good job. All right. So now on to number 12. Now for number 12, you're going to need to use this type of math here, over here. So you might want to take a screenshot of this problem. And then try number 12, and when you come back, we'll do it together. All right, we're back. A squared plus b squared is equal to c squared, and a, we're going to plug in 2 for a, and y for b, and c has to be 2 root 10. We don't have any choice on that. It has to be 2 root 10 because 2 root 10 is opposite the hypotenuse, or opposite the 90-degree angle, which means it is the hypotenuse. The hypotenuse is always the longest side of a right triangle. 2 times 2 is 4. And this is 2 root 10 times 2 root 10. That's what raising to the second power means. You're multiplying something by itself. And I'm going to move this over a little bit. So we learned in my beginning algebra course that when you multiply these, you just multiply 2 times 2 is 4, and root 10 times root 10 is just 10. Or if you want to do an intermediate step, you can say root 100. But root 100 is just going to end up being 10. So 4 times root 100, what number times itself is 100? Well, that's just 10. And then 4 times 10 is 40. You don't have to show all these steps. I'm just showing these so you can see that there's steps to this that we learned in my beginning algebra course. Now we're going to isolate y squared by subtracting 4 from both sides. And we have y squared isolated, but we don't want y squared, we want y. So we have to get rid of that 2 on the y, that 2 power. And we end up with y is equal to 6. So if you got 6 on that problem, good job. So now we're going to do some word problems with the Pythagorean theorem. 2 more problems on the Pythagorean theorem before we go on to something else. How much shorter will Bill's path be if he walks across the grass rather than using the walkway? All right, so Bill's standing over here. He's at this yellow dot, or this red dot here. And he's supposed to walk on the sidewalk, but he's thinking about just cutting across the grass. He's going to cut across this way here, you see, along this dotted line. And we want to know how much distance is he going to save, because it's going to be longer for him to walk around the sidewalk. It's going to be a longer distance than if he just cuts across. So we want to know how much shorter is his path if he walks straight across. Now notice that that we're making a right triangle, you see. This is a right triangle because we're assuming that this is a square or some sort of a rectangle. It doesn't have to be actually it's not a square, it's a rectangle, because we know that this side here is 12 and this side is 9. So it's a rectangle. So we're assuming that these are right angles. So that means that this triangle here or this triangle here, it doesn't really matter which one you use, they're both right triangles. Now this is kind of confusing because you can decide what triangle we want to use. What triangle do you want to use? Which one? Well, I'm going to use this one down here. It doesn't really matter. They're both the same. But I'm going to use this triangle here. And what we have to do is we have to find the length of the hypotenuse, because that's his path. He's going to walk across there. We want to see how long that path is so we can compare it to how long he would walk if he went along the sidewalk. So we're going to look at this triangle here, and we're going to ask we need to find the legs of that triangle. Now we already have a leg here. It's 9. You see, we have one leg is 9, and I'm gonna take this triangle out and put it over here. So this side here is 9. We know that, 9 meters. But this side we don't know. There's no length given here, so it's kind of a trick problem. But we do know that this length is 12. That has to be the same length. That's just how rectangles work. So it's kind of a tricky problem. It doesn't look like we know this length, but we actually do. It's this length here. It's 12. So that's going to be 12 meters. So now it's just a basic problem. And let me get this out of the way here and shrink that a little bit. It's just a basic Pythagorean theorem problem. So we want to find this length here. So we're going to use a squared plus b squared equals c squared. So we have 12 squared plus 9 squared equals c squared. And how do I know? How do I know that this is these are legs? and not the hypotenuse? Well, because the hypotenuse is the opposite side of the right angle, which is the length that we're looking for. We don't know that length. We can call that C, or you can call it maybe D for distance, whatever you want to call it. I'm just going to call it C. So 12 squared, you can get your calculator out if you want to do that. 144, 9 squared, 9 times 9 is 81. 144 plus 81. I'm going to do that on my calculator. 144 plus 81 is equal to 225. So 225 is equal to C squared. Now we're not looking for C squared. We don't want C squared. We just want C. So how do we find C? Well, we just square root both sides. And that's going to be 15. So 15 meters. So at this point, a lot of students would say, okay, well, we're done. We found it. It's 15 meters. Well, that's not what the problem is asking. We've now found that this length here is 15 meters, but the problem is not asking for that length. It's asking how much shorter will Bill's path be. So if he goes along the sidewalk, he's going to walk 12 meters. Then he's going to walk this distance here to get to his destination, but we don't know this distance. What is this distance? Well, again, this distance here is the same as this distance because it's a rectangle. So if this distance is 9, that means this distance is also 9. It's kind of a trick problem again. So if he walks along the sidewalk, he's going to get 12 meters, and he's going to walk an additional 9 meters. So that is, let's see, 9 plus 12 is 21 meters total. But if he walks along the diagonal path, it's only going to be 15 meters. So how much shorter is the diagonal path than the sidewalk path? Think about that. So the sidewalk path is 21 meters, and the diagonal path is only 15 meters. So that's going to be, we're going to add those two together, 12 plus 9, and then we're going to subtract 15, and that's going to be how much shorter his path is going to be. So 9 plus 12 is 21. 21 minus 15 is 6. 6 meters. That is the answer. So again, that was kind of a challenge problem. There's a lot going on there. Let's go on to another problem here. A 10-foot ladder is resting against a wall. If the bottom of the ladder is 5 feet from the wall, what is the height of the top of the ladder? I know that seems kind of complicated, but it's really not. So you have the ground, and then you have a big wall, and you have a ladder. I'm going to make the ladder, let's see here. I'm going to make the ladder yellow. So here's your ladder. The ladder is 10 feet long, and it's 5 feet from the wall. So it might look like that. So the ladder is 10 feet. And the distance from the bottom of the ladder to the wall, this distance here, is 5 feet. We're given that information. And now what they're asking is, what is the height of the top of the ladder? So what they want is, how far up above the ground is this top part of the ladder? How far is this above the ground? That point where it touches the wall. So they're asking for this length. So as you can see, it's just a Pythagorean theorem problem. So let me get rid of some of this here. Kind of move this over. And what I'm going to do is I'm just going to draw the triangle. I'm going to take this out and make it very simple. I'm just going to draw the triangle. It doesn't quite look right. So I'm going to draw the triangle. It looks something like this. So we have 5 feet and 10 feet, and we're looking for x, or you might, let's just call it h, because that's height. So now we're just going to use the Pythagorean theorem. All right, so a squared, and again, this is a right triangle. You might ask, well, how do we know this is a right triangle? Well, this angle is assumed to be 90. Because when you build a wall, usually walls are not built at an angle like this. Sometimes they are, but not, in 99% of the cases, the walls are built straight up. So we know this is a 90-degree angle. So we're going to plug in 5 for A, H for B, and 10 for C. 5 squared is 25. 100 squared, 10 times 10 is 100. Subtract 25 from both sides, and you get 75. Square root both sides. And I'm not going to show the square rooting on both sides. Now we have a perfect square in 75. So I'm just going to factor it to 25 times 3. And then we can pull out the perfect square. Square root of 25 is 5, and then we just leave the 3 there. And again, I'm skipping some steps here because we don't have a lot of room, and you're not really required to show all that. That was just for your benefit at the beginning of the class. So now the final answer is 5 square root 3 feet. I didn't mention in the previous problem, if you don't write meters, you're going to get points taken off in your problems. When you do word problems, you have to write the units that you're given. So 5 square root 3 feet is the final answer on that one. All right, so those were some examples of word problems that use the Pythagorean theorem. Those are some of the most common word problems that you're going to see. So that was the Pythagorean theorem. I forgot that we had those 2 word problems at the end there. But that was the Pythagorean theorem, again, one of the most important theorems in all of the math curriculum. It only applies to right triangles. You must understand that. It only applies to right triangles. All right, now we're going on to the Triangle Sum Theorem. This is a very easy idea. It looks complicated, but it's very easy. What this theorem tells us is that all the angles in a triangle always add up to 180 degrees. So this angle plus this angle plus this angle is going to be 180 degrees. How did I know that? Well, that's the Triangle Sum Theorem. It's always true in every single triangle in the universe. If you add up all the angles, it's always going to be 180 degrees. That's the Triangle Sum Theorem. So the sum of the measures of the interior angles of any triangle is 180 degrees. So if you have some triangle here, the measure of A plus the measure B plus the measure C has to be 180 degrees. Now the proof of this is not that difficult, but again, if I take 100 high school seniors and ask them to prove this, I would be shocked if one of them could prove this theorem. It's not that it's difficult, it's just that students are not required to know it. So given that this course is very difficult and there's a lot of material that you have to learn, I'm not going to make you learn the proof because you just don't have to know it. We may do this proof later on in the course if we have time. All right, so now let's do some practice problems. We're going to do these together, and you can try some on your own later on. This is a typical type of problem that you're going to get. We have 2 angles in the triangle, and we're asked to find the third angle. Well, that's very easy to do because we know that all the angles add up to 180 degrees. So we can make an equation. I know that 88 plus 55 plus x must be 180. Because that's the Triangle Sum Theorem. And by the way, you can take a screenshot of that Triangle Sum Theorem if you want. You can refer back to that. Again, don't worry about collecting a log of all these postulates and theorems because I'm going to give you all of them in a screenshot probably at the end of the day just to make sure that you can refer back to that. Periodically, I'm going to give you a screenshot of all the theorems and postulates that we've learned. But so now we just have to solve this equation. So you can get out your calculator if you want, if you don't feel like adding 88 and 55. 88 plus 55 is 143. We have to simplify first. A lot of students will try to take this and put it on the other side of the equation. or they'll try to take 55 and put it on the other side of the equation. Before you do that, add these up, because it just makes it a lot easier to do it, to simplify the sides of the equation before you start putting things on other sides of the equation. So now we're just going to subtract 143 from both sides of the equation, and we get 37 degrees. And that is the answer. So this triangle sum theorem, as you can see, it's very easy. All right, number 16, we have a right triangle. So if this is a right triangle and we can see this is a right angle, what is the measure of this angle? You tell me. Well, it's 90. So we can use the triangle sum theorem. We know that y plus 90 plus 50 is equal to 180. That's the triangle sum theorem we learned up here. All the angles in every triangle in the universe add up to 180 degrees. So again, y plus 90 plus 50 is 180 degrees. I know that must be true, so that can help me to find the missing angle, which is y. So again, before you start throwing things on different sides of the equation, add up 90 and 50, and we get 140. Then subtract 140 from both sides, and we get y is equal to 40. So very simple. 140 degrees. I got to be sure to put your degree symbol. All right, let's try one more of these problems before you try one on your own. Now we've got a very unusual problem because all the angles are missing. All the angles are y. We don't know what y is. But we can still use the triangle sum theorem. We know that all those angles, y and y and y, they all add up to 180 degrees. Now, we know that if you add y 3 times, we can just simplify that to 3y. Then we can just divide both sides by 3 to get 60 degrees. So dividing both sides by 3, that just gets rid of the 3 on the left side of the equation, and we end up with 60 degrees. So this is an equiangular triangle because all the angles are the same. And it turns out that if a triangle is an equiangular triangle, it must be that the angles must be 60 degrees. That's the only way that could possibly be true. And you can prove that using the triangle sum theorem. All right, so now it's time for you to try. Again, you're just using the triangle sum theorem. All these angles must add up to 180 degrees, and that allows us to find the missing angle. So try number 18, and when you come back, we'll do it together. All right, we're back. 30 plus 135 plus x must be equal to 180 degrees. 135 plus 30 is 165. And subtract 165 from both sides, and we get x is equal to 15. So 15 degrees is the answer. So if you got 15 degrees, good job. Try number 19, and when you come back, we'll do it together. All right, we're back. One of the angles is 90. So 60 plus 90 plus the unknown angle, z, is equal to 180 degrees. 60 plus 90 is 150. Subtract 150 from both sides, and we get z is equal to 30 degrees. So if you got 30 degrees, good job. All right, number 20 is going to be kind of a challenging problem, but see if you can do it. Try number 20, and when you come back, we'll do it together. All right, we're back. All the angles must add up to 180 degrees. That's the triangle sum theorem. Now, x plus x is 2x. That may be the part where you had a little trouble there. You can simplify those x's, put them together, make 2x. Now we just have a two-step equation. So we're going to subtract 30 from both sides. You may think, well, let's subtract let's get rid of the 2 first. Well, you can do that, but you'd have to divide both sides by 2, and that would be a lot more complicated. This would become 15. X plus 15 equals 90. But we want to stay away from that. We want to just subtract 30 from both sides. And we get 2x is equal to 150. Now we can divide both sides by 2 to get x is equal to 75 degrees. And that is the answer. So if you got 75, that's very good. If you didn't get 75, that's okay. But now you know how that problem works. All right, on to number 21. Now we're getting into some challenge problems. We're just using the Triangle Sum Theorem again, no big deal, but we are getting into some challenge problems. All the angles must add up to 180 degrees, and that's going to help us to find x. So we know that if we add up all those angles, and I'm going to use parentheses just to show that each expression is an angle. So we plugged in, this is one angle, this is another angle, and this is the third angle. We know that if we add all those angles up, we get 180 degrees. Doesn't matter what kind of triangle it is, the angles must add up to 180 degrees. So now we can go ahead and get rid of those parentheses. I didn't really need to write those parentheses. I just wrote them so you can see which part of the expression is an angle. So we can get rid of those, and we can just add the x's up. X plus 2x is 3x. 95 plus 5 is 100, and then 100 minus 40 is 60. So all we're doing is just simplifying both sides of the equation. This side is already simplified as much as we can go there. So now we're going to subtract 60 from both sides. This is just pre-algebra stuff. This is just a two-step equation. And in fact, this entire equation here, you learn that in my pre-algebra course. So now divide both sides by 3, and we get 40. X is equal to 40. So we found the variable there. Now, if you didn't take my pre-algebra course and you're a little rusty on this, that's okay. You can learn it right now, or you can go back to my pre-algebra course and go over these equations. But as you can see, it's really not that difficult. But again, pre-algebra is a prerequisite for this course, and beginning algebra is also a prerequisite. So don't tell me that it's unfair to give you these equations, because, again, you need to know what the prerequisites for this course are. Now, if you took pre-algebra and you took beginning algebra and you never learned this stuff, well, that means that your curriculum was seriously lacking, and that's just something you're going to have to deal with. Or maybe you took the course, but you just don't remember it. That's okay. We're going to review with these problems today. All right, so let's try another problem here. Actually, why don't you try number 22 on your own? You should be able to do that on your own. So go ahead and attempt that problem, and when you come back, we'll do it together. All right, we're back. So 4x plus 21 is one angle, and then 90 degrees is another angle, and then 3x minus 1 is the third angle, and if we add all those up, we must get 180 degrees. That's the Triangle Sum Theorem. So 4x plus 3x is 7x, 21 plus 90 is 111, and 111 minus 1 is 110. So all we did was just simplify that left side of the equation. We're going to subtract 110 from both sides, and we get 70. Divide both sides by 7, and we get 10. The variable is 10. So if you got that answer, good job. All right. So why don't you try number 23, and when you come back, we'll do it together. All right, we're back. 4x plus 10 plus 4x plus 10 plus 3x minus 5 must be equal to 180. If you add all those up, you have to get 180. 4x plus 4x is 8x, plus 3x is 11x. 10 plus 10 is 20, minus 5 is 15. And subtract 15 from both sides, and we get 165 is equal to 11x. And 165 divided by 11, you can get out your calculator for that. That would be 15. So x is equal to 15. If you got 15, good job. If you didn't get 15, that's okay. We're going to do more of these problems. So why don't you try 24? I couldn't fit these angles inside the triangles, so I just put little marks there to show you where they are. Try number 24. When you come back, we'll do it together. All right, we're back. We know that the angles have to add up to 180. So we make that equation, and we can use that equation to find x. 100 plus 15 is 115. 115 plus 9 is 124. Subtract 124 from both sides, and you get 56. And 56 divided by 7 is 8. So x is equal to 8. So if you got 8, good job. All right, on to number 25. Now we're going to do some problems that are a little more challenging. We have a triangle, but then we have one of the sides is actually a ray going out into the left, into infinity. And so this is kind of a weird problem here. The variable we're looking for is not one of the angles, and it's not even inside the triangle. So what we're going to do is we're going to find this angle first. Then we're going to use the linear pair postulate to find this angle. So let's call this angle, let's call that y. Let's just pretend that that's y. Now we know by the triangle sum theorem that if we add up the angles inside the triangle, that sum has to be 180 degrees. So now we're going to add 65 and 70 to get 135. Subtract 135 from both sides, and we get 45. So we know that this angle, this y, this angle here has to be 45 degrees. And so if that angle has to be 145 degrees, then this angle x, we can figure that out pretty easily, because if you notice, these two angles form a linear pair. Because when you combine them, when you make them adjacent angles, and they are adjacent angles, they share a vertex, and they share a side. Those two angles, they must add up to 180. They must be supplementary by the linear pair postulate, because they make their non-common sides. Well, you can use all the fancy terms if you want, but you can see that this is just a straight line here. These two angles form, this one plus this one makes a straight line. So those are, that's a straight angle when you combine those two angles. So that means that y, if we call this y and x are a linear pair. So what that means is that x plus y, maybe I should just write y for now, x plus y has to be 180 degrees, because if two angles form a linear pair, then they're supplementary by the linear pair postulate. But if they're supplementary, by definition, they add up to 180. That's what supplementary means. Now we discovered that y is equal to 45, And so now we just subtract 45 from both sides and we get 135. So x is equal to 135 degrees. Now notice that x is equal to the sum of these two angles. You add up 65 and 70 as we did here and you get 135, and it turned out that was the answer to this particular problem. That was x. Turns out there's a theorem called the exterior angles theorem, and that says that the measure of any exterior angle is equal to the sum of the non-adjacent interior angles. Now we haven't talked about exterior angles yet. These are interior angles, and this is an exterior angle. We can make an exterior angle at any vertex by extending the sides, and it gets a little complicated to explain exactly what the exterior angles are at this point. We don't need to do that, but we are going to prove that theorem, that any exterior angle is equal to the sum of the non-adjacent sides. And these are called, or non-adjacent angles, excuse me, not sides, non-adjacent angles. And these are adjacent angles because they share a side. They share this side, this angle and this angle. They both share this side, and they share a vertex. So they're adjacent angles, but these angles are non-adjacent to x because they don't share a vertex. So we're not going to prove that theorem now, but we are going to prove that later on. All right, why don't you try number 26? Again, we have to find this angle first and use that angle to find this angle. So try 26. Remember, you got to use the Triangle Sum Theorem to find this angle, and when you come back, we'll do it together. All right, we're back. So let's call this angle y. And we know that if we add up all those angles inside the triangle, the sum must be 180 degrees. 50 plus 63 is 113. Subtract 113 from both sides, and we get 67. So y is 67 degrees. Now again, y, this angle here and this angle, they make up a linear pair. So they're supplementary, they add up to 180 degrees. So we know that x plus y must be 180 degrees. And we know that y, we found y, and maybe we should do steps here. That's step 1, step 2, put a little divider line. We found y is 67, and now we just subtract 67 from both sides, and we get 113 degrees. Again, that makes sense. It should be the sum of these two angles. All right, so we have 4 more of those challenge problems. And then we're going to do a couple proofs, and then we're going to be done with this class. So again, the main things we learned today are just the basics of triangles, the Pythagorean Theorem, and the Triangle Sum Theorem. Those theorems are so important that pretty much makes up an entire class. All right, so number 27. This problem is going to be more difficult. It's the same principle, but we're going to have to come up with, this is sometimes called a dummy variable. It's not defined as a variable. We're going to make it a variable. We're going to call this y. And we know that 3x minus 15, the sum of all the angles inside the triangle must add up to 180 degrees. So 3x minus 5 is one angle, y is another angle, and 40 is a third angle, and they must add up to 180 degrees. Now we also know that y, this angle here, and also y, they have to add up to 180 degrees. And how do I know that? Well, because again, these are just a linear pair. It's the same principle we were talking about before. This angle plus this angle add up, they make a line when you put them together. So we're going to write that equation. We know that 5x plus 10 plus y has to be 180 degrees. They're supplementary by the linear pair postulate. So now we have two equations and two variables. So what we're going to do is we're going to simplify these equations. Now these are systems of equations. Now you learned how to do this in my my beginning algebra course. We learned systems of equations. There's a lot of different ways to do this, but I'm just going to stick with the way that you learned in my beginning algebra course. So first what we're going to do is we're going to simplify everything. We're going to combine the -5 and the 40. So, and before we go on, I'm going to have to join these equations. I'm going to have to make it a system. Remember, whenever two equations go together, you want to join them with some sort of bracket. So we're going to write 3x plus y plus 35. So I added the 40 and the -5. And then I'm just going to rewrite this equation. I'm trying to do everything very slowly here so you see exactly what we're doing. You don't really need to do it this slowly. You can skip some of the steps. Now I'm going to put the 35 and the 10 on the other side of the equations. So subtract 35 from both sides in the top equation. And you get, let's see, you get 145. Now I'm going to subtract 10 from both sides of this equation here, and we're going to get 5x plus y is equal to 170. So now you can see we have just the typical system of equations that you're used to in my beginning algebra course. Now again, you may be a little rusty on this, that's okay. The best way to do this is with the elimination method. We learned the substitution method and the elimination method. This is going to be really easy because we can just write a line here, and because the coefficient on these two y's is 1, we can just subtract this equation from this equation, and those y's are going to cancel out. So 3x minus 5x is -2x. Y minus y is 0, so I don't have to write anything there. 145 minus 70 is going to be -25. So now we just have to divide both sides by -2, and we get x is equal to 12.5. So that is the answer. X is equal to 12.5. And usually we would go back and try to figure out what y is, but we're really not looking for y, so we don't have to do that in this particular problem. Why don't you go ahead and try number 28 on your own. You have number 27 to refer back to. And when you come back, we'll do it together. This is a challenge problem, so try your best. If you get stuck, that's okay, but go ahead and attempt that problem and see what you can do. Remember, you're going to have to use a dummy variable. You're going to have to let this angle equal y. Attempt number 28. When you come back, we'll do it together. All right, we're back. So we're going to make two equations. We know by the Triangle Sum Theorem that 50 plus 90 plus y is equal to 180. So we also know, and I'm going to make a bracket here, we also know that 4x plus 20 plus y must be 180 by the linear pair postulate. So now I'm going to simplify the top equation, and maybe I should color code these. This equation goes here and here, and this equation goes there. So I'm going to do that here. So I'm going to simplify the top equation. I get 140 plus y is equal to 180. And the bottom equation is going to be, I'm just going to subtract. It looks like this problem is going to be a lot easier. I'm just going to subtract 20 from both sides. And I'm going to get 160. This problem is easier because the top equation doesn't have an x. So I can just solve the top equation, subtract 140 from both sides, and I get y is equal to 40. So I guess we didn't really even need to make a system of equations for this problem. Now we're just going to use substitution because one of the variables is solved for. Y is 40. So just double checking all that stuff. So y is 40, so we can take that 40 and plug it in to this y. So I'm going to take this equation, put it down here. Again, I'm color coding all this. So I'm going to take that equation, pull it down, and 4x plus 40, now y is 40, we know what y is. And subtract 40 from both sides, and we get 120. And 120 divided by 4 is equal to 30, and that is the value of x. So if you got 30, that's a good job. Again, these are challenge problems, so if you're able to do them, that's really good. If you're not able to do them, that's okay. That's normal. As long as you have the main idea down, then you have enough. All right, on to number 29 and 30. Let's do number 29 together. We're going to make a dummy variable again. We'll call this y. And we're going to make two equations. We know that 15x plus 45 plus, actually let's do the triangle sum theorem first to keep it consistent. Y plus 100 plus 8x plus 1 is equal to 180 degrees by the triangle sum theorem. The sum of all the angles must be 180 degrees. We also know that by the linear pair postulate, 15x plus 45 plus y must be 180 degrees because those are supplementary angles by the linear pair postulate. Now we're just going to, again, there's many different ways we can do this, but I'm just going to simplify. I'm going to put the x's first because that's just traditional, and then add 101 to make 101. And I'm going to put the x's first again, and then the y's next to them. This is just the way that you put systems of equations together traditionally. Now I'm going to take I'm going to take the 101 and the 45 and put them on the other side. So I'm going to subtract 101 from both sides in the yellow equation. And I'm going to subtract 45 from both sides in the orange equation. Again, I don't want you to get confused about which equation is which. So now we can just use elimination. Subtract the bottom equation from the top equation. 8x minus 15x is negative 7x. Y minus y is 0. 79 minus 135 is going to be negative 56. Divide both sides by negative 7 and we get x is equal to 8. So that's just another type of challenge problem. Again, these are challenge problems. And why don't you try number 30? And when you come back, again, we have another 90-degree angle. I keep giving you those 90-degree angle problems, those right triangle problems. Try number 30, and when you come back, we'll do it together. All right, we're back. So we're going to call this again, we're going to make this a dummy variable. We're going to call that y. And the triangle sum theorem tells us that the sum of the interior angles of the triangle must be 180. And we also know that y and 4x plus 9, that's a linear pair. Just by looking at the picture, we can see it's a linear pair. And by linear pair postulate, they must be supplementary angles, which means they must add up to 180 degrees. Now I'm going to kind of skip ahead here a little bit. I'm going to add these two up, and I'm going to subtract from both sides. So if you add those up, negative 1 plus 90 is 89. Then I'm going to subtract 89 from both sides. And we're going to get 91. Because we're kind of running out of time here, so I'm skipping ahead a little bit. You don't have to show every step that I'm showing. Alright, so now we're going to subtract 9 from both sides in the orange equation, and we get 14x plus y is equal to 171. And then we're going to use elimination, subtract the orange equation from the yellow equation. And 6x minus 14x is negative 8x. Y minus y is just 0. That disappears. 91 minus 171. You can do that in your calculator if you want. 91 minus 171 is negative 80. Divide both sides by negative 8. And you get x is equal to 10. So if you got 10, good job. So that was the triangle sum theorem. And we're just going to do a few proofs. We're going to do 3 proofs just to finish out the day. And then we're going to be done with the class. It's always good to review 2-column proofs. Show that the following theorems are true with 2-column proofs. So you should know proofs pretty well by now. This is called the right triangle complements theorem. The two acute angles in a right triangle are complementary. So what that means is that if this is a right triangle, we know this is a right triangle because there's a little square there. So we know it's a right triangle. If this is a right triangle, then these two other angles are always going to add up to 90 degrees. That's what that means. If two angles are complementary, that means they always add up to 90. The measures add up to 90. So that sounds complicated. It's the right triangle complements theorem. If you have a right triangle, then the two angles that are not the right angle, but the two other angles, they add up to 90. That's the right triangle complements theorem. So we have to prove that. We know that angle C is a right angle. That is given information because it's a right triangle. So one of the angles must be a right angle. And by definition, the measure of that right angle must be obviously 90 degrees. That's the definition of a right angle. Now we also know that the measure of angle A plus the measure of angle B plus the measure of angle C must add up to 180 degrees. That's a triangle sum theorem. Again, we learned this theorem today, that all the angles in a triangle must add up to 180 degrees. So now, again, we're trying to prove that measure A plus measure B is 90 degrees. Measure A plus measure B is 90 degrees. So we know that measure C, the measure of angle C is 90 degrees, so we can just plug that into this equation. So we're going to take that equation, take this equation here, and we're going to rewrite it down here. But instead of measure of angle C, we're going to plug in 90 degrees because we know measure of angle C is 90 degrees. And you can put your degree signs if you want, or you don't have to. So that is substitution property of equality. Now I'm going to subtract 90 from both sides of that equation, and I end up with measure of angle A plus measure of angle B is equal to 90. That is the subtraction property of equality. And at that point, we know that the measure of A plus the measure of B is equal to 90. So by definition, they're complementary angles. So angle A and angle B are complementary angles. That's the definition of complementary angles. So we proved the theorem. We don't need that last step there. So we proved that if you have a right triangle, the two acute angles, meaning these two angles, the angle other than the right angle, they must always add up to 90 degrees. And we use the Triangle Sum Theorem to prove that. All right, so now I want you to try a proof. You're going to prove a theorem that we mentioned. It's called the exterior angle theorem. And by the way, I'm not going to make you remember this particular theorem. There's a lot of theorems and postulates that are not really that important. We might mention them, but I'm not going to make you remember them. Here's another one that I'm not going to make you remember, the exterior angle theorem. We mentioned earlier, this is an exterior angle. These are interior angles of the triangle, but polygons, like a triangle, they also have exterior angles. This one here is an exterior angle. I can draw a line out here, and this would be an exterior angle, or I can draw a line here, and this would be the same exterior angle. It doesn't matter. I know it's kind of confusing to think about, but it doesn't matter if you draw the line here or here. These two angles are the same by the vertical angles theorem, so they're all the same exterior angle. I know that's kind of confusing, but you can draw an exterior angle on every vertex of a polygon, and that exterior angle is going to be supplementary with the corresponding interior angle. I know that's kind of complicated, but all we're saying here with this exterior angle theorem is that the measure of this angle, this exterior angle, is equal to the sum of these other two angles. That's all we're saying. So see if you can prove that. And it's going to be a challenging task, but given all the information that you've learned, that shouldn't be too hard to prove. You're going to use the Triangle Sum Theorem, and you're going to use the linear pair postulate, and I believe that should be enough to prove that the measure of angle 1 is equal to the sum of the measures of angle 3 and angle 4. Now I'm going to get you started with the first step because it's kind of difficult to figure out exactly what the given information is. In this particular proof, you can just say the given information is the figure. So I'm going to say the figure. And so now you take it from here. Again, you're going to use the Triangle Sum Theorem, and you're going to use the linear pair postulate. Now if you get stuck, that's okay, but try your best. And go ahead and attempt this problem, number 32, and when you come back, we'll do it together. All right, we're back. So now we're going to go to the Triangle Sum Theorem. We know that the measure of angle 2 in the triangle plus the measure of angle 3 plus the measure of angle 4 has to be 180 degrees. Triangle Sum Theorem. Now we also know that angle 1 and angle 2 form a linear pair. So angle 1 and angle 2 form a linear pair. And we can see that just by the diagram. So if they form a linear pair, by the linear pair postulate, we know that angle 1 and angle 2 are supplementary angles. That's the linear pair postulate. So by definition, because they're a linear pair, or because they're supplementary angles, the measure of angle 1 plus the measure of angle 2 have to add up to 180 degrees. The sum is 180 degrees. That's the definition of supplementary angles. All right, so now you can see where we're going with this. We have 180 here, 180 here. So we're going to use the transitive property of equality. Two things are both equal to 180 degrees. So that means they're equal to themselves. So the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 must be equal to the measure of angle 1 plus the measure of angle 2. Transitive property of equality. So now you can probably see where we're going with this. We're going to subtract 2 from both sides of the equation, and we end up with measure of angle 3 plus measure of angle 4 is equal to measure of angle 1, which is exactly what we're trying to prove, and that's the subtraction property of equality. We proved that the exterior angle, the measure of the exterior angle, is equal to the sum of the measures of the other angles, the angles that are not adjacent to the exterior angle. So that's called the exterior angle theorem. So if you got that answer, good job. That was a challenge problem. Don't be frustrated if you can't do some of these proofs. If you get stuck, that's okay. That's perfectly normal. Most students are going to get stuck on these problems because they're challenging. So don't worry if you got stuck on that. We're going to do one more proof today, and then we're going to be done. And I'm not going to give you any proofs, or I may give you one proof or maybe a couple proofs for the homework, but not very many. So let's see here. See if you can try number 33. Now, again, if you get stuck, that's okay. But just try number 33. You're going to use the Triangle Sum Theorem. And I think that's the only theorem that you're going to use. So see if you can do number 33. Number 33 says that if we know that two angles in one triangle are congruent to two angles in another triangle. You see how there's a double arc here and a single arc here? Well, there's also a double arc here and a single arc here. So that means we know that angle 2 is equal to angle 5 and angle 4 is equal to angle 1. So what this theorem says is that if we know that these two angles are equal to these two angles, then the third angles must be equal. So that means 3 must be equal to 6. So again, if angle 2 is equal to angle 5 and angle 1 is equal to angle 4, then angle 3 must be equal to angle 6. So you're going to try to prove that. It's not going to be that difficult of a proof. So it seems kind of complicated, but it's really not that difficult. So try number 33. Use the Triangle Sum Theorem, and when you come back, we'll do it together. All right, we're back. The given information is that the measure of angle 2 is equal to the measure of angle 5, and the measure of angle 1 is equal to the measure of angle 4. That is given. Now, we also know that by the Triangle Sum Theorem, the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 has to be 180 degrees. And we also know the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 has to be equal to 180 degrees. So those are both the Triangle Sum Theorem. All right. So now what we're going to do is we're going to use a transitive property because both these expressions are equal to 180. So we're going to use a transitive property to say that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 must be equal to the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6. And that is the transitive property of equality. So now we're going to use this information up here, and I'm going to plug in 5 here. So I'm going to take this equation, I'm going to rewrite it in this step, but instead of measure of angle 2, I'm going to plug in measure of angle 5. And instead of measure of angle 1, I'm going to plug in measure of angle 4. There's a number of different ways to do this. Now you can see what's going to happen. Well, first of all, that was a substitution property of equality. We're going to subtract measure of angle 4 from both sides and measure of angle 5 from both sides, and we end up with measure of angle 3 is equal to measure of angle 6. And that is the subtraction property of equality. So I just want to go back and make sure you know exactly what's happening here. So we plugged in 5 here, and we plugged in 4 here, and then we subtracted, and we proved that the measure of angle 3 must be equal to the measure of angle 6 given that information, and that is the third angles theorem. That is the class today. Don't leave until you take screenshots of your homework. First of all, go ahead and get screenshots of all the work that we did today. And you can use these screenshots to help you with your homework and also to study for tests. Now let's look at the homework. Get a screenshot of that first page. And the next page. And the last page. Be sure to do that homework completely and correctly and neatly, and keep all your work in order. You need to know where your homework is. Keep it in your binder in chronological order, and I'll look forward to seeing you in the next class.